Now see this question that has been asked in ES 2011. In this question we have to write nodal equation for this circuit. So to write the nodal equation, here we have to analyze this circuit. Here in this circuit we can see that these two nodes are directly connected with this voltage source. It means we can treat this whole node as a supernode. So this is supernode. And take this node as reference. Now we can easily write the nodal equation. Here 4 ampere is entering the supernode, so we can write 4, and this 10 ampere is leaving the supernode, so we can write minus 10 is equals to, here suppose voltage is V1 and here voltage is V2, so we can write V1 by 2 plus V2 by 4. So this is the nodal equation for this circuit. Now here we will not take this 2 ohm resistance because current entering a supernode is equals to current leaving a supernode. That's why we will not take the current through this 2 ohm resistance. So this is the nodal equation for this circuit. Now we are going to solve the question that has been asked in GATE 2017. Here this circuit is given and we have to find voltage VAB. So for this circuit, VAB is equals to VA minus VB. Now we solve this question by using nodal analysis. So to apply the nodal analysis, we have to choose a reference node. Suppose we choose this node as reference node. When we choose this node as reference node, then VB will become 0. So we can say that VAB is simply equals to VA. And what is VA? VA is the voltage of this node A. Okay, suppose voltage at this node is V. Now we can easily apply nodal analysis here. First apply nodal analysis at this node. So on applying nodal analysis at this node, we can write this current is leaving this node, so we can write minus 6 is equals to V by 5, V minus 0 by 5 plus V minus VA by 10, that is equals to 3V minus VA is equals to minus 60. Now apply nodal analysis at this node. Here for this node we can write VA minus V by 10 plus VA minus 16 by 10 plus VA minus 0 by 10. So here we get 3VA minus V is equals to 16. Now we can easily solve these two equations. We have to eliminate this value V, then we get the value of VA. So on solving this, multiply this whole equation by 3, and after that add these two equations, we get 3 V 9, we get 8 VA is equals to 12. Is equals to minus 12. So finally we get VA is equals to minus 1.5 volt. So this is the answer of this question. Now see this question. This question is very important and it will clear your supernode concept. Okay, so here in this question we have to find voltage V1 and V2. To solve this question we need to understand that when two nodes are connected to each other through a voltage source, then this whole combination form a supernode. Here we can see that this voltage V1 and this node voltage V2, these two nodes are connected directly through this 5 volt source. That's why this whole forms a supernode. And we can write it as V1 minus V2. It means potential difference between V1 and V2 is, if I am writing V1 minus V2, it means move from V1 to V2. So when we move from V1 to V2, this positive terminal of battery is encountered. So V1 minus V2 is equals to 5 volt. This is my first equation. Simply write 5. Okay. Now we will see how we can apply nodal analysis to the supernode. So to apply the nodal analysis, treat this node as a single unit. So how we can write? This 4 ampere is entering the node. So 4 plus 9, this 9 ampere is also entering the supernode. So we write plus 9 is equals to V1, treat this node as reference node. So V1 by 1 by 2 plus V2 by 1 by 6. Okay. Now when you solve this, we get V1 2V1 plus 6V2 is equals to 13. This is my second equation. And on solving this first and second, we get V1 is equals to V2 is equals to 0.375 volts. Okay, so on solving this two equation, here two variables, so we can easily solve. V1 is 5.7375 and V2 is 0.375.
If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.